In can fly experiment, we would need a PVC pipe, a cloth, and a can. The first step is to flip the can in a way that can be rolled. Next, we wrap the PVC pipe and place it near the can. We can see it began to roll. This is because the PVC pipe is charged with negative charge, and since the can is neutral, it is being attracted by the pipe. In the stick-around experiment, we would need a PVC pipe, a cloth, a scissors, a match, a piece of thread, tape, and a glass jar. Then we grab the scissors and the match and cut it in half. The half we have to tie it up with a piece of thread that we have. It can be tedious, but with patience it can be done easily. For example, here I try my best to not get desperate to tie it up. After we have our knot, we grab a piece of tape and put it in the opposite side of the match. Next, we grab the jar and place the tape inside bottom of it. We have to make sure it is well placed so it does not fall. Then we have to put it back on the table and wait until it stops moving. The final step is to wrap the PVC pipe with a cloth. Then get close to the glass and we will see that the stick starts moving. This happens because the pipe is fully charged of electrons, so it transfers inside of the glass, so that's why the stick starts moving.
By rubbing the PVC tube on the cushion, we transfer electrons to the tube and it becomes negatively charged. Since the bubbles are neutral, they have the same number of positive and negative ions. When we approach the bubble with the tube, the positive ions in the bubble get attracted by the negatively charged tube because opposites attract. The first try we did, we were unable to generate electrostatic charge. We thought that maybe it could be because the polycarbonate sheet was too thick. So we made a second try, but this time we used a thinner plastic sheet. By rubbing the sheet of plastic with a cloth, we generate electrostatic charge on the surface, charging the plastic sheet negatively by transferring electrons to it. This causes the styrofoam balls covered with aluminum foil to stick to the surface by attracting its positive ions. When we approach the balls with our positively charged hand, the balls get repelled, causing them to move around. The balls continue to move around until all the charges in the balls and the sheet are balanced. In this second way of making the experiment, the same happens, but since it is upside down, the styrofoam balls stick to the plastic sheet and elevate from the surface we are working on. As we can see, the weight of the styrofoam balls may determine if they are able to stick to the plastic surface or not.
We transfer electrons to the PVC tube by rubbing it with cloth, and by this, the charges become negative. When we pass the tube near the water and the foam cup, The water starts bending towards the tube because these two attract each other. We transfer electrons to the balloons by rubbing the PVC tube with a cloth. As well, the charges become negative. The ions of the balloons are negative, and when we pass the tube near the balloons, these repel each other.
As our next project, we're going to do an electroscope which detects the charges by the movement of the PVC pipe and then through the wire, and our material is going to be the metal wire, our straw, a cork, the aluminum foil, a glass bottle, and our PVC pipe. So as a first step, we have to do the electroscope, the magnetic wires. So for this, we're going to bend it in circles in the following way. So it makes a figure and it gets bigger and bigger, our circle. And we're going to continue until we do around 3 full turns in this way. And then we're going to grab our cork and insert a straw through the middle. And we have to make sure that it goes through all the way, as in here. Then we're going to insert our metal wire. After that, at the end of our wire, we're going to make a hook and insert the aluminum foil. In this way, we can insert it through the glass bottle and make sure it goes all the way and there's no air in it. And now we're going to test it. And as seen in the video, we can see that it is electrified.
So for our last project, it's called Wingardium Leviosa, and our instrument we're gonna use is a PVC pipe and a plastic bag. So for this, we're gonna charge both of our materials, and in theory, it's supposed that the plastic bag should be able to levitate thanks to the electromagnetic force that are repelling each other. So our first step is charge electrically our plastic bag, and now with our PVC pipe, and it's supposed to levitate. No? 3. So after trying several times, we can conclude that it doesn't work. There is a force acting, and there is electromagnetic force causing that the plastic bag moves. So my 3 main theories why it's not working, it may be that the gravity force acting upon the plastic bag is greater than the electromagnetic force of the PVC pipe and the plastic bag that is between it. My other theory why it's not working this project may be because the electromagnetic force spread through the plastic bag is not enough, and it's making that it's not centrally charged in one point but through all of the plastic bag. Or it may be that in the PVC tube, it's the electromagnetic force is spreading all the way and not in a single point, so it's not able to levitate. So those were my 3 theories why this Wingardium Leviosa project is not working.
For the hover experiment, we would need 2 plates and a cloth. The thing is to rub the cloth in the bigger plate as hard as we can till we feel it is charged. Then we have to place the small plate, and it's supposed to repel or to get stick in my hand, but somehow it does not work. We believe it was due to the environment, or maybe something else is gaining the electrons we are producing while I'm rubbing it.